Okay, so they're giving us an equation here, and they're wanting us to find the endpoints of the minor and major axis for the graph of this ellipse. The maximum point major. So to do all this, you probably should draw a little graph. I'm not going to draw anything real fancy. I'm just going to go over here and just give the basic idea of this graph. So this graph is going to be, remember what's underneath x, square root of 25 is 5. That's x. So that means this graph goes like over 5 and back 5. And then whatever's underneath y, square 36, 6, it's going to go up 6 and down 6. So here's what the graph looks like. I could draw an egg, sort of. My best without using the tool. So there's the egg shape. It's a little taller than it is wider because there's a little bigger number underneath y squared than there was x squared. Okay, now what do they want? The maximum point on the what's the talking about the major and the minor axis? Well, major is bigger, right? And that's exactly what we're talking about. This is the major axis. Why? Because 6 is bigger than 5. This graph happens to be taller than it is wide. It doesn't totally look like it the way I drew it, right? And maybe, you know what, let me redraw this and kind of exaggerate, because since they're making a big deal out of that, I probably should try to do a little better job than I'm doing. So this graph, it goes all the way up to 6. All the way down to -6. And then over to 5. I'm going to make 5 look like closer than it really is, just for visual effect, just so we can see a little better what it is we're looking at. Let me see if I can draw a nice oval. Yeah, with the tool, there we go. Mine looks off center a little bit, but whatever. Yeah, so this one's taller than it is wide, isn't it? It's taller. So this then is the major axis, and this other one is the minor axis. So the major is the bigger direction. So the major can be up and down, you know, if you had, or it can be sideways. If you had an ellipse that was wider than it is tall, then the major would be the wide one. You know, it's just, major just means bigger. Okay, so what does it want on this then? It wants to find endpoints. Okay, so what's the maximum point on the major axis? So on the major axis, that'd be this point up here. That's over 0 up 6, right? This point here is 0, 6. And then the minimum point on the major axis is over 0 down 6. Be this point right there. Okay, and now let's try to find the maximum point on the minor. That'd be this point right here. And let me try to draw these things where they go. So this is going to be what? This is over 5 of 0. And then the minor point on the minimum axis is that point right there, which is back 5 up 0, back 5 up 0. So there we go. So by just drawing the graph, and that's pretty easy, right? Whatever's underneath x, square root of it, right and left 5, whatever's underneath y, square root of it, up and down 6. So it goes up and down more than it goes sideways. It's taller than it is wide. So the up and down is the major, the y-axis is the major on this one. The x-axis is the minor. It could be vice versa. If you have an ellipse that is wider than it is tall, then the major axis would be the sideways x-axis. It's just whichever one's bigger. The major axis is the one that is bigger. We just put down our 4 points. There we go.